So, geometry, let's go through our learning target today, Thursday the 9th of January. SWBA students will be able to, that's you guys, okay, going to be able to find measures of isosceles and equilateral triangles. So in section 5.1, we talked a large amount about just triangles in general. Okay, we talked about classifying them by their sides, by their angles, okay. We talked about finding some measures based on adding up to 180, thank you, okay. Based on adding up to 180, exterior angles, that kind of stuff, okay. So today, in this lesson, in 5.2 that will start today, we'll finish off next week. Okay, it'll actually be next Thursday, next Wednesday, my dudes, because we'll be math testing on Monday, don't forget that. But we're going to be talking specifically about isosceles and equilateral triangle, okay? Let's first start with isosceles here. Now, we had talked about how isosceles triangles, they have two congruent sides, but they technically can have at least two. But we said if it has more than two, then we just call them equilateral. We don't normally call them both, but you can. So this, what we're talking about here, is talking more strictly about those isosceles triangle with two congruent legs. That's just commonly what we normally think of with isosceles, is just those two congruent sides, okay? So we call those congruent sides legs. So here, these would be our two legs. Those are the two legs of the isosceles triangle. I'd love for you to go and label that on there as well, okay? So we have segment AC is a leg, and what's another leg here? Yeah, segment BC or side BC. Okay, these are line segments that make up the triangle. Line segments are the sides. Line segments going clear back to chapter 1 still, and we've seen really every chapter since then is line segments, okay? And so, does it matter if I call this BC or CB? No, it super doesn't, okay? Doesn't matter if I call the first one AC or CA. It doesn't matter if I even list them in that order. I could put BC first and AC second. It doesn't matter. We're just trying to say, oh, let's just list them. Okay? Is that your question?
No, are we not doing hypotenuse?
Not yet. We'll get to that. Yeah. You're excited about the hypotenuse, though. Okay?
No,
So,
I don't.
yeah. So we also have a vertex angle. Okay? It's a special angle in the isosceles triangle. Now the vertex angle is always going to be the one between the two legs. So what angle is between the two legs? What angle? Yeah, angle C. So angle C is our vertex angle because it's between the two legs. It's where those two legs come to meet. So angle C is our vertex angle in this triangle because it's between the two legs. Okay. Now, since we said the two congruent sides are legs, that means the non-congruent side will be our base. So what's our non-congruent side? What's our base for this triangle? Yeah, side AB, segment AB. Either one, side or segment AB. That's our base. Now, the base doesn't have to be on the bottom. The base doesn't have to be on the bottom, okay? The base is just always the non-congruent side. So if I took this triangle and I just pushed it over, and it looked like this now, the base would be on the right-hand side. Okay? The base would be on the right-hand side instead of the bottom. Okay? So it doesn't have to be the bottom like we would conventionally think the base is something being. It just happens to be the non-congruent side. In this case, it's on the bottom. Most commonly, that's where we'll see it, but it's not always. And then we have base angles. Well, what do you think our two base angles are going to be? A and B, we haven't talked about them yet, so that's probably a pretty good guess. And why do we think we call angle A and B the base angles? They're on the base. They're the two angles that are touching the base. Angle A and angle B are the two angles that touch the base. Okay? Not confused with Finding Nemo and touching the butt, okay, but they're touching the base. Okay, you guys remember that part of Finding Nemo?
Yeah.
Okay. I was watching that movie over break, okay? It's like I watched like so many Disney movies over break, it was awesome. Okay, so like legit, okay, mini story time here. Okay, legit. So when I went on my first date with Hannah, okay, I went to her house, picked her up, okay. And like I said, she lives at home and she has a lot of younger siblings. Now one of her siblings, okay, she's in 8th grade right now, and I walk in, talk to her family for a moment as we're about to go out on our date, and her sister hands me this letter, and so I read the letter, and it's basically saying, hey, I've come to realize, like this is from her point of view to me, I've come to realize you don't know a lot of the quotes and references my sister makes. So she gave me like a to-do list of like movies to watch and like deadlines to watch them by. And she's like, guys, she gave me a ridiculous amount of movies to watch. Okay, she gave me 48 movies to watch. Okay, 48 of them. Okay, and she gave me less than 8 months to complete it. Okay, she gave me 7.5 months to complete these like 48 movies. I'm like, that's way over 2 a week. Okay, and I'm like, okay, ooh. And so I told her, I was like, hey, you know, this is like, and she gave me the deadline by the end of like last calendar year, and I was like, hey, like I'm not gonna hit that deadline, but like I'm gonna try my best, okay? And so right now I'm down to 6 movies left because I went ham over Christmas break and Thanksgiving break, and I crossed a lot more off. So now I'm down to 6 movies left. I'm feeling pretty good about it. Yeah.
You should
Anyway.
watch one in class so you can knock it off.
Yeah. Well, you know how I was telling you I did like nothing that Friday I proposed, and like I just watched Cars. That was one of the movies.
You've never seen Cars?
No, I'd seen it before. The thing was, is I'd seen some of the movies before, but she's like, well, even if you've seen them, I think you should rewatch them, so that way you're up to date. I'm like, so, yeah. But no, I've seen Cars. And like Finding Nemo was on the list, so I rewatched that over break, but I watched that when it came out, and so like I've seen some of these movies before too.
So
But,
did she make 12 references to the movie?
yeah, she just makes a lot of references to these movies, and so she said in the letter, she's like, I like to think of it as Hannah's second language, and so I need to know what she's saying. Was the idea. So yeah, so I told her I'm gonna take it seriously, and I'm like, hey, I'm gonna finish them all before the wedding. So I've given myself another 5 months and 18 days to finish 6 movies, which I think is pretty doable at this point. Way more than 48
Are you gonna tell
movies.
us every day?
I count every day, so it's 171 of them, by the way, in case you're wondering. Okay, so we have this base angles theorem, okay, for isosceles triangles. Okay, so we're saying, hey, if these two sides are congruent, go ahead and mark that on your picture. If those two sides are congruent, we have two sides congruent, so we have an isosceles triangle. Then these two angles are going to be congruent. If we have these two sides congruent, then we have these two angles congruent. Now, what kind of angles are these? What did we call them just a moment ago for my story? Base angles, okay? We call them base angles. Because if these are the congruent sides, they're called the legs. So that means this non-congruent side is called the base. So these are the base angles. So we're saying, hey, if the legs are congruent, the base angles are congruent. That's a theorem. It's always true, 100% of the time, okay? Gracie, how often is that true? 100% of the time, okay? So, I love when you caught on while I was there, you're like, okay, anyway. So, if we have these two legs congruent, the base angles are congruent. And where do they happen to be? They happen to be directly opposite those legs. And that's always going to be the case, okay? They're opposite those congruent legs, so those are the congruent angles. That's another way we can think about it, is they're opposite the congruent legs, okay? Converse, what's it mean for the converse? We talked about that idea a lot. What? Opposite how? Is it adding not? No, which one is it then? Flipping them, switching the order. So the first part is second, and the second part is first. So what do I think my first picture is going to be here? The base angles being congruent. And then what do you think is going to be true then in the second part? Those legs being congruent. Very good. So if the base angles are congruent, then those opposite sides, the legs, the opposite sides, boop, 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 happen to be congruent as well. Okay? It's always the case. So if you have two angles congruent, it's going to be an isosceles triangle. If you have an isosceles triangle, two legs congruent, those base angles are congruent 100% of the time. Okay? Questions on that? Yeet. Okay. Let's go right below this. Let's apply this. Okay? Now I know it says extra example, and it even says extra example too. Well, first of all, it's our first example. Second of all, it's not extra. It was just from the resource it was pulled from. They happen to call it extra example, but I'm not calling it extra. It's just the example we chose. Okay. So we have this triangle, and we're asked to find the measures of angle x and z. We're asked to find x and z. Okay. Well, let's ask ourselves some questions here. What kind of triangle is this? Isosceles. How do you know it's isosceles? Two congruent sides. We just did a lot of that in our homework, right? In that orange packet, that kind of salmon colored packet there. Okay. So we just did that. We have these two congruent sides, so it's isosceles. Now, what did we just learn about these two base angles? They're congruent too. That was the theorem we just had. So, do we know the measure of them yet? We do? We're told they're this many degrees? No. What could we call it though? X. If I call this one x, what do I call this one? X. Why? They're the same. They're congruent. Can I now make an equation? What equation can I make? 50 plus x
Equals 180.
equals 180, because all three angles in a triangle add up to 180. Okay, so we can do 50 plus x equals 180. Questions on how we got this equation?
What's that base angle?
We're going to ignore that for a moment. We're going to come back to that afterwards, actually. Okay? Because I think it's way easier for us to think about it this way. That's the secondary way. So 50 plus x equals 180. What's x plus x? 2x. 50 plus 2x equals 180. Now what do we do?
Divide 130
Okay, we said to subtract 50, then we can't do that. And I heard someone say once we do divide 130 by 2, x is equal to 65 degrees. 65. So what's the measure of angles x and z? Yeah, so measure of angle x. Try that again. Measure of angle x and measure of angle z are both equal to 65 degrees. So this whole base angles thing, the whole isosceles triangles have two congruent angles, that's going to come in handy for these, okay? It really will. Casey, okay, how'd you do it? Okay, and it worked the same way, right? It worked the same, right? Okay. Okay. Now, some people, okay, that brings me to the next point, okay, so thank you. Some people, this will be a lot easier for you to think about. Some people, what we did will be a lot easier for you to think about. I want to give you both options here, and I want you to pick whichever one's best for you, okay? I'm all about trying to give you options when I can, okay? And this is one of them. So we said a base angle. Well, x and z, we said are base angles, right? Okay, which is why they were congruent in this isosceles triangle. So we said base angle, which is what we were trying to find, so we made that our x, is equal to 180. Where do we think this 180 comes from?
It comes from all of them.
All the angles.
Yeah, all the angles out of 180. Minus our vertex angle. What's our vertex angle here? 50 is between the two legs. And divide by 2. Why do we think we divide by 2?
Because
Two angles.
There's two base angles, right? Okay? And now let's look at this math, okay? So we take 180 minus 50. Well, that's 130. Over here, did we take 180 minus 50?
Yeah.
And we got 130. Okay, so far our math is the same. We did 180 minus 50. We did 180 minus 50. Then what did we do? 130 divided by 2. Did we do the same math here? 130 divided by 2? Yeah. So are they actually even different at all? Technically, no. Which is why they both work. Okay? They just look a little different. They're just kind of packaged differently. It's like, hey, can I copy your homework? Sure, just change it so the teacher doesn't notice, right? Okay? It's basically the same thing. Okay? So, they both end up getting the same thing. We both do the same math. We subtract 50, we divide by 2, either way. Some people, some of you guys might have a better time of remembering this. Some of you guys might have a better time remembering this. Whichever one is easier for you, that's what I want you to do. Okay? Math is the exact same. Okay? Does that make sense? Yeah, I'm just giving you guys options. Cool beans! Okay, you guys ever watch Hot Rod?
Yes.
Okay. Cool beans! Cool beans! Cool beans! Anyway, it's a scene from the movie Hot Rod. It's hysterical, okay? I highly suggest you watch it. It's really funny. Anyway. What?
You're just a goof.
Yeah?
It's so funny.
I've never denied that once in my life. Nor will I ever. Yeah. You saw, did they say goon or goof or goof?
I said goof.
Okay, because they would all be true. So,
You ever watch
Yeah.
Goonies?
no, I still have it.
You'll watch the
Never
Goonies.
No, I know, I know I need to, okay?
I've only seen it like
Really
twice.
good.
Is that on your list?
No, it's not on my list though, but it probably should be. Yeah.
Alright, when you see how you have to get into the gate, whenever you, like, I don't know if you own your
Oh
own
yeah,
house
yeah,
already,
yeah, yeah, I've seen that part.
You need that.
That big old system or the truffle shuffle?
Oh, both.
Okay,
How do you know? How do you know what the truffle shuffle is? You've never
it's
seen
so popular.
it. I have no idea.
That's how I know, because like everyone references, but I've just never seen the movie.
We should watch it in class.
Probably not.
How about during finals week?
Oh yeah, totally not. Okay, if I ever propose to Hannah again and meet the day to do nothing, we can watch it, but that won't happen. So I already proposed her once, so I don't need to propose again. That'd be
Oh,
weird.
what?
What? No. Okay. Anyway, let's go to this bottom example here. Okay. We're supposed to find the length of the sides. We have a triangle here. Of course we have a triangle. That's what we're talking about in this chapter, okay? I want you guys to think about this one on your own. Analyze it. See if you can figure out a way to try and solve this problem. Okay? It's a little challenging. Okay? But I want you guys to think about it individually for a moment, okay? So see if you can figure out a way that we could find the lengths of these sides here. Okay? So think about what we've been talking about, try some stuff out, see if it works, okay? I want you guys to take a moment and try that, please and thank you, okay? Challenge yourself here. No. It's worth asking.
Okay.
Okay, now I want you to compare somebody next to you. Okay? Even if you don't have anything written down, talk about what ideas you've had, if any. Say like, hey, I haven't had any ideas. Have you? Okay? Hey, oh, here's an idea I had, but it didn't work. Okay, talk about those things with someone next to you, okay?
I did the same exact thing.
Jessica, why don't you come over here and talk to Mackenzie or Wyatt, whichever one of someone else.
Wow, there's something there.
Well, what are you trying to say? What did Jessica talk to me?
She could have, but I assume that with the way you guys are arranged right now, it was more likely that you were talking with one of those two than they were talking with each other.
I always told her. 'Cause then-
Nice. That's pretty good. Gotta say it, JP though. Gotta be able to keep up with my players. Maybe fresh shave.
I mean,
Do we know what colors we're
I
gonna do?
get what you were doing
Okay.
before.
No,
I think you combine,
fully.
you combine one half.
I think in a couple different shades of gray. Last year we did like kind of like a green.
I get what you're going for.
Oh, she's talking about. Yeah, so close.
Remember. Yeah, but
Oh, wait, but these are, okay.
So you guys see in different
they
shades,
equal the
right?
same
Yeah.
as the equation.
No, so it'd be kind of doing a few in each side. But, hey, anyone have any ideas on what we could do here? Anyone come up with anything?
Nope.
Yeah, Brayden, what'd you come up with?
So you could have 6x minus 4 equals 4x plus 4.
Okay, how'd you arrive at that idea?
Well, because it's an isosceles triangle, so those two sides have to be the same length.
Okay, how do you know it's an isosceles triangle?
Because the two base angles are the same length.
Okay, so we have these two angles congruent. Well, the theorem above us, the converse, tells us that if these two angles are congruent, that these two sides have to be congruent.
That's not true though.
Okay.
That's a lie.
Is it?
Yeah.
I don't think so.
Stoner, it's not a government conspiracy.
So it's not like birds being drones. Okay, this isn't true. Okay.
Are you
So-
sure about that?
Okay, so Braden's right though. Braden's right. That is what we do. Okay, these sides are congruent because these angles are congruent. So the sides opposite the angles are congruent. And so whenever we see congruent, we say, oh, we can set those equal to each other. Because once we solve this equation, what can we get? We can get what is equal to? X. We know what x is. Okay? So you can subtract 4x, 2x minus 4 is equal to 4. Add 4, 2x is equal to 8. What does x end up being?
4.
4. Okay? Now we were asked to find the length of all the sides, so how can we go about that?
Plug it in.
Plug it in, right? Okay? So over here, what do we end up doing after we plug it in?
You get 5.
Okay, we get 5, because 2 times 4, solve. Give me minus 3. So we get 8 minus 3, so it is 5. So we can say the measure of side AC, or segment AC is 5. Or if we're just doing it on the picture, that'd be okay. Okay, but if we don't have a picture, this would be how I want us to list it. Okay. Does anyone know what AB was? 20, very good. Okay. Plug 4 in, 6 times 4. 6 times 4 is 24, ha ha. 24 minus 4 is 20. So the measure of side or segment AB is 20. Now what should we already know about the measure of side BC? It's 20 as well, right? Now what if we plug it in though and we get something different? You did something wrong. We have to check it. But it does end up being 20, which is good. And after you write down these 3 side lengths, yes, you may have it.